Hello everyone, today I am going to explain the third problem of Leetcode Weekly Contest 321, which is remove nodes from linked list. So we are given a linked list, and we have to remove node which has a node strictly greater than the value of anywhere on the right side of it. 5 to 13, 3 and 8. So this node 3 has a node 8 which is greater than 3, so we should remove the 3. Now 5 and 2 both has a node 13 which is greater than both, so we will remove 5 and 2, so our resulting linked list will be 13 and 8. So now this problem is quite straightforward if we want to create a new linked list. So what we will do, we'll just store everything in an array and take the sub. So let's just explain this brute force approach here. So 5 to 13 3 8, so the brute force approach will be, this is a linked list, so let's just convert it into an array 5 to 13 3 8. Now we'll just store the prefix max array 5 to let's build the prefix max array. So 8, for 3 it is also 8. This is 13 13 13. So this is suffix max, not prefix max, sorry, my bad. So we this is the suffix max array. So first step will be just store it into a link array. So first array from linked list, then we are just building this suffix max array from this. Now we'll just iterate from the front. So 5, the suffix max from I plus 1, 13 is greater than 5, so we should not include it. 2, the suffix max is 13 greater than 2, so we should not include it, so just delete this. Now 13, its suffix max is 8 which is less than 13, so we'll just create a node 13 from the linked list. Now 3, whose suffix max is 8 greater than this, so we should not include this also. Now 8 has suffix max, let's consider here it is 0, so 8 has a suffix max less than 8, so we'll just add this node into the linked list. So the it will pass because it is order of n and we are just doing 3 passes. So order of 3 into n will be the time complexity of this. You can do this and it will get accepted. Now let's explain more intuitive solution, which is order of exactly 1 pass and order of n. So how I have solved this problem, I have used recursion in this problem. So let's say we are at, let's say this is the linked list. Okay, so this is the head and this is the first node. What is our given linked list? 5 2 13 3 8. 5 5, this is 2, this is 13 13. Now this is 3 and this is 8. Okay, 5 2 13 3 8, and this is done. So now we'll just do some recursion. So let's say we are at index 5. Now let's say we are at index 8. Now what we'll do, we'll just call a recursion on head arrow next. So we'll just do an recursion on head arrow next, and this will return two things. This will return the value of modified head. This will return two things. One is modified head, and second thing is the suffix max. So it will return suffix max in one pass. So from recursion we can get suffix max is one pass. So let's say we are at 5. 5, from 5 we can go to 2, we can go to 13 3 8. Okay, 13 3 8. Okay, now let's say we are at the last index 8. Now when we are at last index 8, so if head is equals to null, so from 8 we try to jump into its next is null, so 8 is null, so we'll just return some null. Modified head will be null, and our suffix max will be -1. So now we'll just check if 8 is greater than the suffix max, so we can say 8 is greater than -1. So we'll just create another linked list which is 8 and null. 8 and null. Okay, now what we will return from here, we will return from here this linked list. This linked list will return the head of this linked list 8, and what is the suffix max? Suffix max will be 8. So what we are returning, we are returning this linked list, modified linked list, and suffix max value 8. Now we are just checking 3 3 is less than 8, so we are not including it, so we are just returning 8 and this linked list. Now 13 is greater than 8, so we will just add this 13 at the start of this linked list. So we'll just add 13 at the start of this linked list and we'll just return 13 and this linked list. Now 2 is less than 13, so we will not include it, and 5 is less than 13, so we are not including it. So finally we will return 13, 8 and null. So this will be our desired linked list, 13 and 8. Okay, I hope you got it. So 13 and 8 will be our linked list. Okay, this is the approach. So now let's go through the code. So here I am doing recursion on head, and here I am building one linked list. So sorry, not a linked list, this is a type of a node. So what is I can use pair, but instead of pair I am using some like user defined structure. So the first thing of this is head, the modified head, and this is the suffix max. Okay, I have already explained. So if the head is null, we'll just return new node of modified head will be null, and the suffix max will be -1. Now if the next arrow max is, so next arrow suffix max, we can call it as suffix max also. The suffix max of the next is greater than head arrow val, we'll just do car equals to next arrow head. Okay, so let's say what I am doing here. So let me explain. Let me explain this thing. So from after iterating from 8, so now we have 8 comma null, and we are at index 13. So at 13 I am checking, the suffix max will be 8. 13 is greater than 8, this is the head, and this is the maxi. So head arrow val is greater than next arrow maxi. So 13 is greater than 8. So what we are doing is that 13 is our current head. 13 is our current head. Okay. And here we are fixing head arrow next equals to next arrow head. So this is next. This linked list is called next. So what we are doing, 13, the next of 13 will be 8. So we are just creating a link here. So our new node will be 13, 8 and null. Okay, 13, 8 null. Now if next arrow maxi and head arrow val greater than head arrow val, so if 13 is greater than 8, so our new head will be 13, else our previous head will be 8. Okay, so I hope you got it. As here we are creating a new node car comma maximum next arrow maximum head arrow val. It is quite straightforward. We are just taking the suffix max and we are returning the car node, and at the end we are returning the modified head. I hope you got my explanation. If you still had any doubt in any part of the video, please comment in the comment section. I will go through each and every comment and try to answer everyone. And please like the video and subscribe to my channel. Thank you.